Last equilibrium topic is LeChateliers principle. And as you can see right here, this is the definition. Again, we're just using the very basics so that you can do what you need to for your final exam. LeChateliers principle essentially states that if you have a reaction at equilibrium, okay, remember equilibrium is a reversible reaction, so forward and reverse reaction happening. If that reaction is at equilibrium and something changes that equilibrium, something causes an equilibrium shift, then the reaction will naturally counteract that change so that it can reestablish equilibrium. Now the types of changes that we're talking about, there are 4 of them. The first one is a change in concentration. Remember that those little square brackets, those are, oops, sorry, let me go back. Those are concentration brackets. So adding more or removing some of a reactant or product. 2 is temperature, so increasing or decreasing the temperature. 3 is the volume or the pressure, and we'll talk more about that when we get to that. And then the 4th is a catalyst, and you just watched a video earlier on what happens with a catalyst. Okay, so we're going to deal with each of those 4 changes separately. First is concentration. This is the reaction that we're going to use for each of them. Now, remember, a lot of times that you'll see reactions with the heat outside of the equation, the delta H outside the equation, and you'll have to put it back in. In this case, I have it written within the equation. The concentration is a change, either an increase or a decrease in one of your reactants or products. So in this case, A, B, or C. So let's go through a few of these. An increase in A. Now, one way that I've heard it described as, if this helps you remember, is you can think of concentration in terms of like piling on a lot of dirt. Like you have a dumpster coming and putting a pile of dirt on top of A. You have to spread it out. In order to spread out A, you're going to have to move it in the forward direction. So if you increase the amount of A, then it will move towards the products, which is the direction that will increase, or which is the direction that will get rid of a bunch of that A that you just added, because you have to counteract that change. Now, if I decrease the amount of B, that would be like digging a big hole. I'd have to move towards B, or in the reverse direction, in order to make more of it. Again, a change is happening, and we have to naturally counteract that change. So for that first one, the amount of A is increasing, so we have to move in the direction that will get rid of it. And for the second one, the amount of B is decreasing, so we have to move in the direction that will make more of it. If I increase the amount of C, I'll have to get rid of the amount of C that was just increased, so it's going to move in the reverse direction. And then if I decrease C, I would have to move in the direction that would make more of it. So I would be moving in the forward direction. Next topic is temperature. There is a much more complicated endo-exothermic explanation with temperature, but we're going to do it the easy way, and that is we're going to use that exact same reaction, and all we have to do is treat heat as a reactant or a product. So what we're going to do is, if we increase the heat, that means that, okay, again, our heat is right here. If we increase the heat, that means that we need to move in this direction to get rid of that, which means that it will move in the forward direction. If we decrease the heat, then we have to move in the reverse direction in order to essentially replace it. Last one is volume. Again, same reaction. This is probably one of the more challenging. for volume, we have to look at the number of moles, and we do that by looking at the coefficients. So you can see I already have it underlined on the reactant side. We have 2 of A, 1 of B, so that's a total of 3 moles. On the product side, we have a 2 C's, and that's all that's over there, so it's just a total of 2 moles. Now what I'm going to do here right on the top here, a lot of times we look at this in terms of pressure. Now remember that volume and pressure from gases have an inverse relationship. So as one of them increases, the other decreases. Whatever you're given, so the change, if you're given your change in volume, put it into pressure. Okay, this is easier to understand in terms of pressure. So for example, if I tell you that the volume decreases, you can also, or I'm sorry, that the volume increases, you can also think of that as a decrease in pressure. Now think about a container, and if I have 3 moles in one side, 2 moles in the other, the side with 3 moles is going to have a lot more pressure. So if the natural change that I made is to decrease the pressure, I need to move to the side that is going to naturally increase it, which will be moving towards the reactant side because there's more moles. If I look at the opposite, so if I decrease the volume, that means that it's a natural increase in pressure. Oops. Sorry again, I'm still learning this program. Okay, if I decrease the volume, that's a natural increase in pressure, which means that I need to move to the side that's going to decrease that pressure to counteract the change, which would be moving towards the right. And the last thing, I'm just going to have this written in here quick. Catalysts, and I'll read it in a second here. Catalysts make both the forward reaction and reverse reactions faster. Okay, if you think about, and I'll see if I have a little room to write this here. If you think about a reaction that looks something like this, and then the catalyst looks like that, it lowered the activation energy for both the forward reaction and the reverse reaction. So it doesn't actually change the equilibrium, so there's no equilibrium shift, nothing to do with LeChateliers principle, because it makes both of them move faster and they're still at equilibrium. Okay, so those are so really you don't need to know anything with catalysts. So the 3 that you need to know for LeChateliers principle is how to handle it if there's a change in concentration, how to handle if there's a change in temperature, and how to handle if there's a change in volume or pressure.